check out my nose. Oh man, I'm sorry. Okay. It's Loop Dark Snout here, and it's time to be serious. This is part 4 of BackBit Impawsible. This is the part where I take my 8,730 bitmaps and convert them into character sets, or try to at least. And the problem basically is you have a bitmap. It's 1,000 unique cells. Now, sometimes there are repeats, so let's say it's 800 unique cells. And you want to pull out 256 of those to shuffle around and copy or whatever, and try to recreate that bitmap the best you can. How can you do that? How many variations are there? I thought I could brute force my way through this and pull out, well, one at a time. I would try to find the best candidate and blah, blah, blah. There are not millions, there are not billions, there are not even trillions of combinations. Mathematically, this is how many possibilities there are of pulling out 256 characters from a pool of 800. Can you still see me? Yeah, this many. There hasn't been a quantum computer invented that can solve this yet. But, lucky me, I did not realize that this was the scope of the problem I was attempting to solve. Anyway, there are 2 things that you need to know before I start going off on these tangents here. The concept of pixel difference, and that is where you take one cell of the original bitmap, or a character, whatever, and you compare it to another cell of the original bitmap or another character. 32 pixels versus 32 pixels. Now, there's only 4 choices for every pixel here. These are multicolored pixels. 00, 01, 10, 11. So just add them up. How many match? Or more importantly, how many do not match? Because the pixel difference is the main metric on how almost every decision in these programs is made. And how effective a routine is weighed down to a different value, the global mismatch. And that is where you take the character set you came up with and the 1,000 cells of your video matrix, and one by one you compare them to your original bitmap, adding up all the pixel differences. That is your global mismatch. And the lower the number, the more effective the routine you came up with. And there you go. I think you guys have enough to go on now, so let's get started with the big long journey of turning these bitmaps into character sets. And where else to start than with Character Maker 1? Start at the beginning, yes. So here, you guys go watch these clips while I go check out my nose. Yeah. All right, see you guys later. The stuff I wrote to the color RAM, I forgot to set bit 3. Now that I'm dealing with the character set, I have to specify that this is actually multicolor. And yeah, I'm using the SuperCPU here. This thing is a super dog at regular speed. I'm going to have to make this much more efficient. Every time this counter loops around, it's adding 1 character more to the image. Now watch, it'll change soon. Well, it's hard to tell where it put it, but at this rate, this is with the SuperCPU in fast mode. It's going to take probably almost an hour, maybe less, because this is going to exponentially start going, well, maybe not exponentially, it'll go lower. It'll be about 860 when it loops. 850 something. It used to be 860, 870. Yeah, but anyways, this is not going to work. It's interesting to see it come along. I'm going to let this one happen. Probably when it's done, it's going to crash because the next routine I haven't debugged either. But interesting just to see it go. Yeah, screw it. I'm going to try a different frame altogether. Of course, the first time around, it's just upping what was set by basic. So once it gets to, I guess, about 5,800 or so, 6,800, it's going to start looping from zeros. Because I just took over the the sprites internally to debug this stuff. It is currently 10:37 p.m. Let's see how long this image takes. Ooh, a big jump right off the bat. I like this. It's more fun to watch than What's-Her-Face anyway. Oh yeah, the reason why it resets the count at around 700 and something here, check it out, it'll change in a moment. It only increments the count when it's scanning the screen, but it finds a new cell to do a screen-wide scan with. Now, I have a 1000 byte matrix of used. These are things that are duplicated in the bitmap, so let's not use them again and compare them multiple times every round. And every time a character is added to the character set, that associated cell in the bitmap is also flagged as used, so it won't try to bring it back in again. So I'm guessing basically it should stop when it either perfects the picture and cannot improve it by introducing a new character, or we run out of characters. So I forgot what it played at on the first round when it scanned for duplicates, but basically that value, let's say it was 800 minus 256, that's when it gets to that value, that's when it will stop. And I checked my code, I reran this a couple minutes later. I believe it's going to just drop to basic, and so you'll see a little blinking cursor somewhere, but location 648 is not changed because the screen is set for 4400 hex. The character set is set for 4800. No, 5000, because 4800 and 4C00 are both my pixel difference matrix and the work flags, like our used flags. These sprites are at between 4000 and 42C0. So yeah, there's very little wasted space here, and it doesn't matter that location 648 isn't changed because basic is not going to be doing anything here. But anyway, it's starting to look like a picture. Oh, this is exciting. And it's currently, see that, 10:45, taking into account the 2 minutes that I've wasted resetting and making sure everything was well. That's too bad, though, that this is going to take a frickin' lifetime. It's slow speed with the SuperCPU disabled because I cannot count on this loading in bitmaps without interference. It will take probably a human lifetime. So, yeah, I'm just doing this for fun now. I realize that this is not going to be the best way to go about this, but wow, it's starting to come together. Look at that. That's cool. This is still a character set. And I don't know how many characters we have right now. I mean, I could bust out of here and bring in blah, blah, blah. I was thinking of tweaking this, use my sprite values and show a progress on this program of how many characters the current frame has. So this would be the current frame, which isn't doing this anymore. And this could be how many characters have been assigned. Neat. But this is the first day I got this working. Like what do we got here? This is This is today's stuff. So yeah, this is just initial tests. It took me a while just to get it to here, but yeah, exciting. Okay, I'll shut up. Anyway, I looked at an earlier clip I just made. I do estimate rather accurately now with that when this gets to 530 or so, that's when I will run out of characters. So that's about as good as we can hope for to fine-tuning this particular image. I mean, it looks recognizable, but I wouldn't say it's good. But then again, let's see, where does this stop at the moment? We still have over 100 characters to introduce here. Hopefully that can, smooth out some of these edges and get the guy's mouth going and maybe the eye. And we'll see how it goes, because as the algorithm is designed to do, it takes every possible new candidate and pretends, what if it put it here, put it there, and it'll choose whichever candidate has the greatest number of cell mismatch improvements. So yeah, it is now 11:03. So it's been at this for, maybe 20 minutes or so. I'm running out of characters. Look at this. I have probably about 30 left. It's not looking too good. That's too bad because I have worked a long time on this. I put all my eggs in the, let's see if I can get it at 24 frames a second basket. Bummer. I might have to, try a different approach. Or just go screw it and see what I can do bitmap style. And forget the color restrictions that are forced on myself, because if I'm doing a full-blown bitmap, I can go back and read the original bitmaps better and take advantage of the extra colors per cell. This is going to end any second now. I wonder what it's going to look like in the end. Well, I will show you this exact frame with my my quick test viewer that uses the actual bitmap that was generated instead of this character set equivalent. It's kind of a bummer, but that's the fun of doing a project like this. Just chasing your tail. Kind of looks like he's got a puffy cheek, doesn't it? Like he's chewing some gum or something. Here's a couple of stragglers. Well, they're the same character, but they shouldn't be there. The yellow is because it doesn't know what color to make it. So yeah, these are, it's kind of neat. They're appearing because they're useful at a different spot, but not here. Now, one way that I was planning to take care of that is add up all the color events of cells that are actually referenced and by the color RAM, and just plop them down as the most common color, which in this case will likely be dark green. But then again, I got the colors backwards because this is supposed to be dark blue, this is supposed to be light blue. I got my I might have to get to do this again. Good. And besides, what's the deal with this? I thought it was going to stop at about 5:30. Okay, this guy's getting a bad case of acne. I'm not sure if my program is working correctly. Perhaps it's hit its limit, but it just doesn't realize it. So now it's just, going into no man's land. Stop screwing up. Okay, at this point, I'm just curious what happens when this loops around 0, because this is looking like crap. So I'm just curious how badly I screwed it up. It just stopped. Now I have the background changing at every step of the way, so I'm not sure if I even have a cursor here or not. Let's change it to white. I don't know. Maybe it's locked up. Just tried the stop restore combo. It's completely pooched. Nothing's getting me in. Don't worry. I've tried it. So, there was something. Yeah. Let's see if it's my program's still there. Let's just run it again. See what happens. That's where we started before. So that tells me when it runs out of characters, it's pooched. Oh, damn it. I wrote over all my characters with the initializing stuff. And here we go with the new image. It's currently 11:33 p.m. After a certain point, it always starts to go batty, so that's actually good news, because maybe my routine is, well, bugged in some way that's actually taking a lot longer than it could to execute. So there might be hope still. I'll have to look at this more carefully later. Well, I fixed a couple bugs in my program here. I might actually get this working, and I definitely need to optimize it. He's looking good, and I've got a lot of characters left to go before the set is full. And there it is. This is 3 kilobytes, a character set, and the color RAM. Well, 4 kilobytes because it needs a video matrix too. But still, that's pretty cool, because, you know, it was originally, I guess, 10K, now it's 4. And here's what that same image looks like in my video player debug test thing. How identical is it? I don't know. I mean, I got the SuperCPU still running here. So if I let go of the pause button, check this out. Yeah. Oh, you saw that little blurb? That's what you get when the SuperCPU is running. And there it is after almost a half an hour. Well, yeah, we got dots up here. We got a jagged leg. I think one of the things that I'm doing wrong is how I handle the duplicate characters. If there's a series of duplicates, it should pretty much assign them a character and lock them in, because that's as good as they're going to get. But in this case, I think when I ran into a duplicate early on, it would flag it as used, and then allow the very last one to become the one that it checks. But by then, it's already decided that this is a great sky, and to use like, well, a perfect one only improves it 1 pixel every cell. So yeah, I got more work to do. That's if I wanted to even do it this way, like say half an hour times 10. That's the minimum factor that the SuperCPU is speeding this up by. So 300 minutes divided by 65 hours per frame. So 5 frames a day, right? 9,000 frames in total. What is that? Oh boy. 1,800 days? Yeah. How many years is that? 5 years. No, I don't have 5 years. And there it is. Character Maker 1 turns out to be actually rather good at what it does. I do improve it even more than I've shown in this video, but the drawback remains that it is very slow. So begins the next leg of the quest. Can I find a better way of doing this? Something faster, something more efficient, and possibly something even better. Well, we'll find out in the next episode what I come up with. Anyway, until then, I'm Loop Darksnout.